All right, so let's dive right into learning some Python. And so first things first, we need to start it. So from a terminal, and we know we're at a terminal because of this $sign on the left, the $sign prompt. From this terminal, let's start Python. And all we have to do is type the word Python and press return. And once we do this, we see that the prompt has changed to this caret, caret, caret. That's our sign that we're inside the interactive Python interpreter. And this is where we're going to live for much of the first part of this course. The interactive interpreter is really good for sort of practicing and doodling around and making mistakes because the feedback is really quick. So all you have to do is type in a line of code and press return, and Python will execute that code for you. So really convenient for practicing. So a good way to get into Python is just to use it as a calculator. So let's go ahead and do that. And as I type, actually, please type along with me. And this is actually important because what we're doing as we type, as we practice, is we're building up a muscle memory around what it feels like to type Python programs. And that's going to be important for feeling and developing a fluency in the language. So please do go ahead and type along with me. Okay, so Python as a calculator, it's going to work just like you would expect from math class. So for example, addition works the way that you would expect. 2 plus 2 really does equal 4. You can deal with non-whole numbers. 1.5 plus 2.5 equals 3.75. You can do subtraction. Python knows about negative numbers. Multiplication works the way that you would expect. You can do division. In Python, in general, the white space within a line doesn't matter. So for example, 1 plus 2 with spaces is exactly the same as 1 plus 2 without spaces. Order of operations works like you learned in math class. If you want to force an order of operations, you can use parentheses, just like you can on a calculator. So for example, if we wanted to say, the quantity 1 plus 2 overall multiplied by 3, we can specify that with parentheses. And variables work like in math class. So if you remember, harkening back to elementary school, you might have said x equals 4. And then you can, x is now a pointer to the value 4, to the number 4, and we can now use x in further expressions. So we could now say, x times 2. And 4 times 2, x is a pointer to 4, so 4 times 2 equals 8. X plus 5 equals 9. So great. And the rules for variable names are pretty simple. It basically needs to be a sequence of letters and underscores and numbers. So basically all one word. So for example, you could say magic number equals 1500, or you could say amount of flour equals 0.75. As long as it starts with a letter and it's a single word containing letters and underscores and numbers, you're good to go. All right, and through this process of using Python as a calculator, we've actually secretly learned about not one, but 2 types of data in Python, 2 types of numbers. And we can prove this to ourselves using this thing called type, this function called type. And let's look at it, and then we'll talk about what's actually going on here. So if we type out the word type, and then inside parentheses, some piece of data, some object in Python, like the number 1. So if we say type, the name type, and then inside parentheses, the number 1, and press return, type is a function. So type is a function that takes input and spits out output. It takes as input some object, and it spits out what data type Python understands that object to be. So in this case, the number 1 is an int. It's an integer. It's a whole number. And if we look at the type of 1.0, we see that this is a new class. It's a type float. So this is a number that understands decimal places. So in fact, Python considers these distinct data types 1 and 1.0. And sometimes when you're doing math, you care about whole numbers or you care about decimal places. And Python has 2 distinct data types to handle that distinction. So this is cool because we already have 2 data types under our belt and because we had an opportunity to learn about functions. So a function is just a name and inputs, and it encapsulates a useful bit of work that it does on those inputs and spits out the corresponding output. So like functions in math class, but as we'll see, much more powerful and much more flexible. So we have 2 data types, integers and floats. And we know that we can use a single equal sign to do a variable assignment. So I can say x equals 4, and now I can use the variable name x in further computation. And we've learned about this thing called a function, which encapsulates a useful bit of work, and it takes input and produces output. And the first function that we learned is type. And type takes as input some object, like the number 1, and it spits out what class, what type that object is. Let's learn about a new data type in Python, a new data type called a string. And a string is really useful, and we'll use it a lot. It's a funny name for a really simple idea, which is just a sequence of characters, like numbers and letters and white space and punctuation, put together. And the hallmark of strings is that they are surrounded by quotes. So here are some examples of strings. We have the string hello. We have the string O'Reilly. And we can use this type function from before to confirm that this is in fact a new data type. So if we say type and then a string, like the word hello in quotes, we see that type tells us that this is a new class, a type str, a type string. So strings are going to be how we print and communicate with the outside world. We can smoosh strings together. We can concatenate strings if we want to build up complicated sentences or complicated pieces of information. So for example, I could say hello plus. So plus is how we concatenate strings together. So hello plus world. And this produces a single string that is those two strings smooshed together, so hello world. In fact, hello, it's very literal. So hello world with no spaces. And if I wanted to have a space in the corresponding, sort of the resulting text, I would have to supply that space myself. And we can do this in at least 2 ways. So one way is hello with a space inside the first string plus world. Or we can actually use the plus sign. We can concatenate as many strings as we want in a row. So I could say hello plus the empty string plus world. Variables. So math class, variables are just numbers, but in Python, you can assign a variable to any data type, including a string. So for example, I could say, okay, well, my name is Jessica. So name now points to the string Jessica, and now I can use this variable in further useful work. For example, in a string concatenation. So I could say hello plus name. Beautiful. Astute viewers may have noticed that while I've been using double quotes when defining my strings, or when interacting with strings or typing in strings at the interpreter, sometimes the way that Python displays the resulting output is with single quotes, like here. And that's totally fine. So Python actually treats single quotes and double quotes identically. All you have to do is be consistent. So I could say hello with double quotes, or I could say hello with single quotes, and Python treats them the same way as long as what I use on the left is the same as what I use on the right. So that's the story on double quotes with strings. Well, so here's a question for you. What is this? Well, we can use that rule from before, right? So it is the number 1, but it's inside quotes. So if it's inside quotes, it's going to be a string. And we can prove this to ourselves with that type function from before. So what is the type of the quote 1 quote? Sure enough, it is a string. Here's a question for you. We know that we can add numbers. I can say 1 plus 1. We know that we can add or concatenate strings. I can say hello plus world. What happens if I try to add or concatenate a string and a number? I could go either way on this, but let's try it out and see what happens. So if I press return here, interesting. So this is a traceback. It gives us a type error. Python is saying, uh-oh, I didn't know what you meant here. And it gives some useful information about what the problem was, so we can go back and correct it. And it's really important to get comfortable with this idea of tracebacks, because we'll see them all the time. We'll make mistakes all the time, and that's totally no problem. It's very easy to read this and just correct what was wrong. In this case, the traceback says, oh, this was a type error. I don't know how to convert an integer into a string in the way that you want. Like, I know that you want to make the 1 a part of this string hello, but in Python, there's no idea for that. There's no way to just smoosh integers and strings together. So I need more instructions for how to do this. And fair enough, great, we can fix this. We can actually fix this with a new function. So remember, a function is just the name and then input inside parentheses, and it'll spit out output. And there's actually a function that will take a number and convert it to a string. So let's see what that looks like. So we have the number 1, and I can use this str function. So str is the name, and then it's input inside parentheses. So str of 1. If we type this and we press return, we get a 1 in quotes. Beautiful. So now we can use this function to apply this transformation on the number 1 and concatenate the result with our hello string. So for example, we could say hello plus str of 1. And what do we expect to happen here? Well, we know that we can concatenate strings, and we know that the str function turns a number into a string, so this should work. So let's try it out. Very good. So as we're playing with these strings and concatenation and new functions, a pro tip here is that you don't have to keep typing in things that you've already done before. At the interactive Python interpreter, you can use the up arrow to sort of move back up through previous lines of code that you've executed. Let's definitely remember to do that and spare our hands as we keep going through this material. So for example, if I wanted to try this out with a float instead, no problem. Strings are just a sequence of characters in some order, so strings have a notion of a length. And it's pretty common to care about the length of strings, and fortunately there's a function in Python that will tell us the length of a string. Its name is len, and it takes as input, inside those parentheses, the string that we want to find the length of. So for example, the string hello, the length of string hello is 5, as we'd expect. You can actually, in addition to being able to add strings or concatenate strings, you can actually multiply strings, which is a little bit funny, but it's kind of a fun side effect of the language. So for example, I can take the string A. Again, we know it's a string because it's inside quotes. And we can multiply it by a number if we want. It produces lots of A's. We could say the variable H equals happy. The variable B equals birthday. And then we can do some crazy math on these variables. So let's think about what this would do. Okay, so H is the string happy, B is the string birthday, H plus B, we know what that does. Python will concatenate those inside parentheses, so it does the concatenation, and then it's going to multiply it by 10. So mentally, let's think about this output. Okay, and let's see what happens. And this is a good example of, what it is that Python does when you have a complicated statement on one line. It sort of does each piece in turn, right? So first it says, okay, because of these parentheses, first I'm going to add H and B, and then I'm going to multiply by 10. And we could even do more work here, right? Like we could say, okay, take all of this and tell me the length of this overall operation. And Python is happy to do this. So it's really sort of unpacking each piece in turn until you have done the whole operation, and sort of nesting these operations on one line. There's one other detail about strings and about variables and about output more generally that we're going to need to talk about now because it's really important, but we'll actually mostly use this concept later on. And it's related to being explicit about when something is output that should be sent to a user. So here's an example of this. If we type just the string hello, or there's just a piece of data that we type at the interactive interpreter and we press return, we see that Python mirrors that for us. Or similarly, if we assign a variable to a value, we can type in the variable and press return, and Python will sort of remind us of what the value is. And this only works interactively. So it's great for us while we're doodling around, but this doesn't work in files. And so when we start writing more substantial programs in files, we need a more explicit way of saying this is supposed to be output to the user. And the way that we express that was with a new function called print. So let's take a look at print. So it's just the name print, and then inside parentheses, the string that you want printed. So for example, hello. So if we type this and we press return, we see that it looks very similar to the above, where we just had the literal word hello, the literal string hello. But using this print function ensures that this is actually displayed when we run it from a file. So we're going to really try to get into the habit of using print because it's the way that works across all of the ways that you can interact with Python. The expressions inside the print function, so the input to the print function, can be as complex as we want. So for example, we had this name from earlier. I can assign the variable name to point to the string Jessica. I can, inside this single expression, the input to print, I could say hello plus name. And Python knows how to handle this. It'll say, okay, you want to combine the string hello with the string pointed to by the variable name, and that's the overall string that you want me to print. And this prints what we would expect. The big thing to think about here is we want to use this print function when we actually mean this is output that is supposed to be displayed to the user, because that's what will work in files and more complicated Python expressions. So that is printing. Keep it in mind. We'll see a lot of it later.